Welcome back. Today's lesson is rational numbers. Our standard is 6NS7. Understand ordering and absolute value of rational numbers. I can represent rational numbers in different forms as well as on a number line. So we're going to see decimals and fractions again today. So much fun.
She's serious. It really is fun. All right, first thing we're going to practice is showing both decimals and fractions on a number line, but now we're going to have our negatives in there. So it is going to take a little bit of stopping and thinking to kind of get these set up. So draw our first one here. We want to plot the point negative 2.4 on our number line. So in order to do that, we have to set up the number line. So think about negative 2.4. That's in between negative 2 and negative 3. It's partway in between it. So negative 2 goes at the top, negative 3 goes at the bottom. Remember, for our negatives, it goes down as we're going through it. And then we're counting by tenths, so we're just going to count by tenths on our number line. Negative 2.1, negative 2.2, negative 2.3, got to squeeze it in there, negative 2.4. No, you can't just stop because that's the one you wanted. You have to have a complete number line. Negative 2.7, negative 2.8, and negative 2.9. And then we're plotting the point negative 2.4. So that's where we put the X, or the mark, on our number line to show where it falls along the line.
I'm stealing a pen.
It's going to get ugly, folks. Be careful.
Hey. All right, negative 6.8 is our second problem. This time we're going to display our number line horizontally. So we need to think that negative 6.8 comes between negative 6 and negative 7 on our number line. So negative 6 is closer to 0, so that should go on the right-hand side of your number line. And negative 7...
Hurry up, come on, you're kind of slow.
We need to start counting towards our negative 6. So negative 6.1 comes over here.
Towards our negative 7. From the negative 6.
Whatever. I'm just focusing on writing. Negative 6.3. Yes, I'm writing upside down. Does that bother some people? Negative 6.4.
Remember, she asked to write on this one.
Heck yeah. Negative 6.6. Negative 6.7, negative 6.8, negative 6.9. Well, whatever. Negative 6.8, we need to put an X right here where we identify the integer in the problem. Actually, it's a rational number, not an integer, but whatever.
Now we're going to do the same thing with our fractions.
Change your pen color. They're bored of blue. Purple, yes.
I always like purple. So we want to graph the fraction negative 4/5. So negative 4/5 is less than 1 whole, so we're in between 0 and negative 1. 0 goes above the negative 1 on a number line. And then we're counting by fifths. So I'm going to have negative 1/5. Look at how much nicer that handwriting is. Negative 2/5, negative 3/5.
If you don't practice, you don't get better at
negative
something.
4/5, and then remember negative 1, same thing as negative 5/5. You got to have the whole thing numbered, evenly spaced, and then we want negative 4/5. So we're going to plot our X at negative 4/5.
Yours has fifths, mine got tenths, and you expect me to keep it even, whatever. Negative 3/10.
Notice how mine were already divided up for me.
Yes, what a sneak. So we're going to start 0 over here on the right, and we're moving to 1, which is also, or negative 1, which is also negative 10 over 10.
So remember, because we're counting with the negatives, it kind of goes backwards from what you normally would have expected. Let's see how evenly she can do it. So there's 5, 6, 7. Squeeze it in the 8 to the 9. It's close to even.
Whatever. Negative 1/10. Negative 2/10. Are you going to allow them to use decimals since it's in tenths?
No. But it's okay that some of these fractions are not in simplest form. Since we're counting by tenths, we want all the denominators to stay the same. So don't change it into negative 3/5 or something like that. Keep them all as tenths, please.
I'm running out of room.
Just
And
squeeze it in
that
there.
is much better. So negative 3/10 would fall towards the 0 on the number line.
So that's how we plot our numbers on a number line. Now we have a vocabulary term. You've heard Mrs. King refer to it as a rational number a couple times. So we need to get that into our notes. Sorry if the green is hard to read. It looked cooler before when I set it up. A rational number is any number that can be written as a fraction. So that's your positives, that's your negatives. It's your decimals and your fractions.
So you need to remember from the last unit, what are the two methods that you can change a fraction? Any number. Are we doing into a decimal, right?
Yep. So these two,
Yeah.
we're going to change our fractions into decimals. We're
So-
good at this, but please jot this note down in your notes. When you're turning a negative fraction into a decimal, the negative sign just goes along for the ride. Don't worry about the negative. It just stays in front of the number, and you just do your steps.
Unfortunately, 7 doesn't go into 100, so we're
Remember your
nidoing it.
nido. Numerator goes on the inside. Denominator goes on the outside. It's a good old dividing problem. And remember, 7s don't play very nicely. We know we're going to have to add in our decimal and some zeros, so just get it out of the way right away. 7 goes into 4 0 times, so we go to 40. 7 goes into 45 times, which is 35.
7 goes into 57 times. Are we just keeping going or what?
Well, we got to keep going a little bit, so we add in a 0. 7 goes into 10 one time, which is 7. 3, let's add one more 0.
Which is 4.
It's 30, so that goes in 4 times.
28. This is a never-ending.
This is one of those ugly ones where this decimal is going to keep going on and on and on and on. Now, one last piece. It was a negative number, so the negative goes on our
It's got to end
decimal.
eventually, or it'll be an irrational number, just so you know.
I know.
All right. -2 and 19/25. That one, I got the easier problem, converts very nicely into 100. There's 4 quarters in a dollar, so 25 times 4 is 100, and 19 times 4 is 56? 6,376, sorry.
There we go.
So now we need to change it to a decimal, which means -2 cannot get lost in this problem.
So remember the whole
Decimal
number just
place.
goes along.
76, please.
76 hundredths, so it ends in the 100 spot. But the negative just kind of hung out for the whole time. So it's really just the same thing we've been practicing before. The negative just tags along. Last piece, absolute value. Guess what? It works the exact same way as it does before. It's just the distance back to 0.
Yep.
-0 and 85 hundredths is 85 hundredths away from 0. So its absolute value is 85 hundredths. You can take this one. We can leave it as a fraction.
-4/13, the absolute value means that it's 4/13 away from 0.
You can do the last one.
Absolute value of 5.9 means that it is 5.9 away from 0. So the only time an absolute value can be negative is when the negative is in the outside, like -3/12. You would have the opposite of -3/12. Then you can bring the negative along. But if it's in the inside of the absolute value, then it's how far away from 0, so your answer will be positive.
I just throw that one in there at the end.
Why not?